This is an applied Newton's law problem that has three boxes that are tied together. They are on a flat surface and there is no friction. We are going to start off by drawing the free body diagram for each object. When we draw the free body diagram for each object, we're going to include all of the forces that are acting on that object and none of the other forces that are in the problem. So box A just has three forces on it. Its weight, which acts down, the normal due to resting on the surface, which acts up, and the tension from the rope, which is labeled 2, and which acts to the right. Okay, now let's do the free body diagram for box B. B has four forces. It also has a weight, which acts down, and a normal, and it has a normal due to the fact that it's sitting on that surface. The normal acts up, and it has two strings attached to it. String 1, which acts to the right, and string 2, which acts to the left. Okay, finally, let's do the third box. The third box also has four forces acting on it. It has the normal, which acts up, the weight of C, which acts down. It has force F from being pulled to the right, and the tension in string 1, which acts to the left. Now that I have my three free body diagrams, I'm ready to apply Newton's second law to each one of them. For box A, I am going to sum up the forces in the x direction, which is just T2, and set that equal to the mass of A times the acceleration of A. Now we will do B. So we are going to sum up all of the forces that are in the x direction, only x direction, and set those equal to the mass of B times the acceleration of B. And finally, we will write Newton's second law in the x direction for C. So again, I'm going to sum up all of the forces in the x direction and set that equal to the mass of C times the acceleration. All right, so I am looking at this and I am going to box up three equations just to help me kind of focus on what equations I have and what unknowns I have. And there you have it. I have three equations and three unknowns, so this should be solvable. Let's just check out what I was given in this problem. I was given the tension in string 1, and I was given what the masses are. So let's get that information organized. And what I am looking for is F. So the force of this that is on the string or in the tension in the string that's on the right. Okay, so it's just algebra from here. I am going to take the Newton's second law equation for box A and substitute in its mass. Then I will take the box B equation and substitute in my knowns for that as well, which include both the tension in string 1 and the mass of B. And finally, I will take my last equation there and substitute in what I know as well. So T1 and the mass of C. All right, so my algebra plan is going to be to take T2 from the equation on the left and substitute it in for T2 in the equation in the middle. Then I'm going to take that middle equation, solve it for a, and substitute that into the equation on the far right.